For these two examples, we're asked to factor completely, and you're going to notice that you're going to actually need two factoring methods to complete. We factored both of these. So the factoring methods are listed here: GCF, difference of squares; trinomials, difference of cubes; sum of cubes, or grouping. So I always start with checking for a GCF. Do they share a number in common that divides both, or do they have a common variable? So for number one, checking that, I do see that they both share an x. So I'm going to factor out an x. So x times x squared gets me back to x to the third minus x times 81 gets me back to 81x. So checking what's left in the parentheses, if I could still factor this using any other method, we've already done GCF, so that one's finished. I do need to continue factoring. So I notice that inside the parentheses, it only has two terms, has a minus sign in between them. So in terms of the options, I would get rid of grouping. I would get rid of sum of cubes because there's no plus sign. Difference of cubes, well, x squared is not a cube, so I would get rid of that. It's not a trinomial because it only has two terms. So difference of squares would be the only option here. So it is a minus sign. The question is, are both of the terms squares? Can you take the square root of x squared and can you take the square root of 81? And the answer is yes. So difference of squares, you open up double parentheses, you alternate the signs, one's a plus, one's a minus, and then you split this front term in the front spots here. So you're saying, what is the square root of x squared? Or what can you multiply by itself to get x squared? X times x. And then in the back spots here, you split 81, and you say, what do you multiply by itself to get 81? 9 and 9. So my final answer still has the x in the very front because you did factor that out from the very beginning. So this would be factored completely. For number two, going down my list, I always check for GCF first. So is there a common factor? Anything that divides 5 and 45? And the answer is yes, 5 divides both of those. They don't share any variables, so I'm just factoring out a 5. So 5 times x squared gets me back to 5x squared minus 5 times 9 gets me back to 45. So I'm done with GCF. So I'll cross that out. Going down my list, grouping fails because there's only two terms left in the parenthesis. There's no plus sign, so it's not the sum of cubes. Difference of cubes, 9 is not a cube and neither is x squared, so that's out. It's not a trinomial, it doesn't have three terms, so I'm checking for difference of squares again. So can I take the square root of both terms? And the answer is yes. So double parentheses, alternate the signs. Remember, your 5 just goes in the very front still. So for the first term, what can I multiply by itself to get x squared? That would be x times x. And then the back term here gets split up in the back spots. So what do you multiply by itself to get 9? 3 and 3. So this would be factored completely.